Your body isn't failing you. It's been running a longer race than you realized. And most people quit right before the finish line shows up. You've done the things: 8 glasses of water, the occasional salad, maybe a gym membership you used for 3 weeks in January, and still the fatigue creeps back. The joints ache a little more. The mirror looks a little older than the calendar says it should. Here's the thing nobody tells you. Aging isn't one process. It's 10 small ones running quietly all at once, inside cells you'll never see. And if you're only fixing one, say diet, while ignoring the other 9, your body compensates by aging faster somewhere else. That's not a guess. That's biology. I know. That sounds strange. Stay with me, because this changes everything. Think of your body like an old building with 10 separate maintenance crews: plumbing, electrical, structural, waste removal. If 9 crews show up and one never does, the building doesn't collapse right away. It rots from that one neglected corner. Slowly, quietly, until one day, the damage shows up somewhere you didn't expect. That's what's happening inside you right now. Here's what most people completely miss. Aging isn't just wrinkles and gray hair. At the cellular level, it's a molecule called mTOR. Think of it as the foreman who decides whether your cells build new material or clean up old, damaged material first. When mTOR stays switched on too long, from constant eating, constant stress, constant stimulation, your cells never get the order to clean house. Junk piles up, damaged proteins, old mitochondria, cellular debris that should have been recycled years ago. Not because you lack discipline, because your biology never got the signal to stop and clean. This was never your fault. Here's where it gets counterintuitive. There's a Nobel Prize-winning scientist named Yoshinori Ohsumi who spent his career studying exactly this cleanup process. He called it autophagy, your body's built-in recycling system. Auto, meaning self. Phagy, meaning eating. Your cells literally eat their own damaged parts to survive, but only when you give them the chance. And most people, without knowing it, never do. What happened next in his research surprised even other scientists. He found that this recycling system isn't always running. It switches on only under specific conditions most modern lifestyles accidentally block, meal after meal, day after day, which means the fatigue you feel, the slower recovery, the skin that doesn't bounce back the way it used to. It might not be age catching up to you. It might be a cleanup crew that's never been allowed to clock in. And once you understand which 10 habits control that crew, which ones switch it on, and which ones keep it locked out, everything about how you approach aging starts to look different. Because there's one habit in particular, something almost everyone does daily, believing it's harmless. It's quietly doing the opposite of what you think. That habit is snacking, not junk food specifically, just eating small amounts all day long. Here's the part nobody talks about. Every time you eat even a handful of almonds, even black coffee with cream, you spike a hormone called insulin. And insulin does something important. It tells mTOR, the foreman, to keep building, which means the cleanup crew, autophagy, gets sent home. Constant grazing means constant insulin. Constant insulin means your cells never get a long enough window to clear out the damaged material piling up inside them. Not because you're weak, because your body is doing exactly what it evolved to do. Build when fed, clean when fasted. It just never gets the second half of that instruction anymore. And that's where everything changes. Here's the protocol. Simple, sequenced, biological. Morning. Delay your first meal by at least 90 minutes after waking. Black coffee or water only. This keeps insulin low and extends the cleanup window your cells started overnight. Midday. Eat your largest, most protein-rich meal here. Eggs, fish, leafy greens. Protein gives your body raw material to rebuild once cleanup finishes. Timing at midday means you're not spiking insulin right before sleep, when repair should be happening instead. Evening. Stop eating at least 3 hours before bed. This is non-negotiable. Growth hormone, which helps repair tissue overnight, gets suppressed when insulin is still circulating. Give your body a clear signal. Building time is over. Cleanup time has started. Movement. A short walk after your midday meal. Just 10 minutes. This helps muscles pull sugar from your blood without needing extra insulin, keeping that cleanup window open longer. Every step here has a why. None of it is random. Here's what changes everything. These habits aren't separate fixes. They stack. A longer overnight fast plus a post-meal walk plus earlier dinners doesn't add benefits, it multiplies them. Each one extends the window that the next one depends on. This was never about willpower. It was about giving your body permission to do what it already knows how to do. Your body wasn't broken. It was waiting. And once autophagy switches back on, something else starts happening. Something researchers only recently connected to a completely different part of your cells, a structure at the tip of your DNA that quietly counts down every time your cells divide. Next time, we go there. Because what shortens it, and what one Nobel Prize-winning discovery revealed about slowing it down, might change how you think about aging entirely. The hidden countdown inside your cells that decides how fast you age. You've been measuring the wrong thing this whole time. Not your weight, not your blood pressure, not even your cholesterol. There's a countdown running inside every single cell in your body right now. And nobody ever showed you where the clock is. Here's the thing nobody tells you. At the very tip of your DNA, there's a protective cap. Scientists call it a telomere. Think of it like the plastic tip on the end of a shoelace, the part that keeps the whole lace from fraying apart. Every time your cells divide, that cap gets a little shorter. Not because something's wrong, because that's what it's designed to do. I know, that sounds strange. Stay with me, because this changes everything. The problem isn't that telomeres shorten. That's normal. That's supposed to happen. The problem is how fast, because for some people, that shoelace tip wears down in slow, steady, decades-long fashion. For others, people the exact same age, eating similar food, living similar lives, it frays twice as fast. Same calendar age, completely different biological age. Here's what most people completely miss. This isn't random. It isn't just genetics either, though genetics plays a role. A molecular biologist named Elizabeth Blackburn, who later won the Nobel Prize for this exact discovery, found something that stunned the scientific community. Chronic stress wasn't just making people feel worn out. It was physically shortening their telomeres, measurably, cell by cell. Not because they were weak, because their bodies were responding exactly as they were designed to under prolonged threat. This was never a personal failure. It was a biological signal, misread for decades as a mood problem instead of a cellular one. Here's where it gets counterintuitive. Blackburn's research team studied mothers caring for chronically ill children, women under sustained long-term stress. The ones who'd been caregiving longest had telomeres that looked, biologically, up to a decade older than their actual age. What happened next surprised even the researchers. It wasn't just the stress itself doing the damage. It was how the body perceived that stress, and whether it ever got a real chance to recover. Because there's an enzyme called telomerase whose entire job is to rebuild that fraying tip, repair it, lengthen it back out. And it turns out, this repair crew doesn't work well under constant pressure. It needs something specific to switch back on. Something almost nobody structures their day around, even though it costs nothing and takes no willpower at all.